JEE Advanced 2025 Chemistry Paper 2, Question 5. This is a multiple correct type question. Let us first review the types of intermolecular forces and their distance dependence. Ion-ion interaction goes as 1 over r, charge-dipole interaction goes as 1 over r squared. Dipole-dipole interaction between rotating polar molecules goes as 1 over r6. Dipole-induced dipole interaction also goes as 1 over r6. And London dispersion forces between nonpolar molecules also go as 1 over r6. The question asks the correct statements about intermolecular forces. Let us read the 4 options. The key concepts are the distance and temperature dependence of various intermolecular interactions. Ion-ion potential goes as 1 over r, ion-dipole goes as 1 over r squared. For rotating dipole-dipole, the Keesom interaction, the average potential goes as 1 over r6 and depends on temperature. Dipole-induced dipole, the Debye interaction, goes as 1 over r6 and is temperature independent. London dispersion forces arise from instantaneous dipoles and attract even nonpolar molecules. Option A says the potential energy between 2 point charges approaches 0 more rapidly than between a point dipole and a point charge. Ion-ion potential goes as 1 over r, while ion-dipole goes as 1 over r squared. Since 1 over r squared approaches 0 faster than 1 over r as r goes to infinity, the ion-dipole potential approaches 0 more rapidly, not less. So option A is saying the opposite, it claims charge-charge approaches 0 more rapidly, which is wrong. Option A is incorrect. Option B says the average potential energy of 2 rotating polar molecules has 1 over r cubed dependence. The Keesom interaction for freely rotating dipoles goes as 1 over r to the 6, not 1 over r cubed. The 1 over r cubed dependence is for fixed dipoles. For thermally averaged rotating dipoles, it is 1 over r6. Option B is incorrect. Option C says the dipole-induced dipole average interaction energy is independent of temperature. The Debye interaction, dipole-induced dipole, has the formula V equals negative alpha times mu squared over 4 pi epsilon 0 squared times r6. There is no temperature term in this expression. So it is indeed temperature independent. Option C is correct. Option D says nonpolar molecules attract one another even though neither has a permanent dipole moment. This is absolutely true. London dispersion forces arise from instantaneous fluctuations in electron density, creating temporary dipoles. These temporary dipoles induce dipoles in neighboring molecules, leading to attraction. This is the only force between nonpolar molecules like noble gases. Option D is correct. The correct answers are options C and D. Dipole-induced dipole interaction is temperature independent and nonpolar molecules do attract through London dispersion forces. G-tip, remember the distance dependence hierarchy, ion-ion is 1 over r, ion-dipole is 1 over r squared, and all the van der Waals forces, Keesom, Debye, and London, go as 1 over r6. Only the Keesom, rotating dipole-dipole, interaction is temperature dependent. Debye and London forces are temperature independent. Like and subscribe for more JEE Advanced solutions at MathPyHub.